All right, let's start with number 7. Here's the example problem. You can take a look at the process. We just have to simplify this. We've got a fraction with a lot of things. We know that we need to cancel some things to slim this down. And you might be tempted to cancel out these x squares here, but no, you cannot do that because there's a plus sign and a minus sign in between. And so what we have to do is we have to break this down by factoring. So let's think about factors of 10. Factors of 10. I've got 1 and 10. I've got 2 and 5. That's it. So it's one of those. Well, 2 and 5 gives me 3 as long as the 2 is negative and the 5 is positive. That also gives me negative 10. So here we go. We're going to put this as x minus 2, x plus 5. There's our factors. Now already you can see that this is better for canceling and dividing, because remember, the dividing is the opposite of multiplication. So I have two things being multiplied. All right, now let's look to the bottom. Factors of 12. I've got, let's see, 4 and 3. I don't know why I started there. 1 and 12 would have been a better place to start. 2 and 6. Those are all my factors of 12. We can see 2 and 6 as long as they're both negative. Well, beautiful thing is, negative times the negative is a positive, and if we add them, we get a negative. So here we go. X minus 2, x minus 6. Now, I know that there's a minus 2 there, minus 6 there, and a plus 6 there, or plus 5 there. So there's still minus and plus signs. But really what we have here is a type of problem that looks like this. Let's say I say 2 times 3 over 2 times 4, right? Think about this. That's 6/8, right? Well, what we're doing when we're reducing is really dividing by a common factor. How do I show that common factor? With multiplication. So now that those things are multiplication, we can reduce. So only in this step can we go through now and reduce that x minus 2 and factor it out. I really divided it out of the top and bottom. So our final answer here is just going to be x plus 5, x minus 6. This is the most simplified version of our original. Done. All right, number 8. Number 8, slightly different. Here we go. We got a monomial, one term on top, two terms on bottom. All right, we might be tempted just to cancel out these x's, but we can see that there's a plus sign down here that's blocking us from being able to do anything like cancel out those x's. We can't do that yet. And so what we've got to do is, again, we've got to turn this into multiplication. Now the top, there's nothing we can really do on the top, so let's just leave it for now. Let's leave it as 4x to the 5th. We could kind of separate it with time signs, but let's just leave it for now. And on the bottom, let's see. Okay, I can see that they both have a 20 and they both have several x's. So let's use GCF here. 20x, they both have two x's, an x squared. And so let's actually divide that out of the first and the second. If I divide it by 20, I get 1. How many is left over? Just an x left over. And then 20x squared, if I divide that out of this 20x squared, I'm just left with a 1 whole, right? Think about distributing to check. 20x squared times x. And 20x squared times 1 would give us back to the original. Okay, now this isn't our factor. This isn't simplified, but this is factoring so that we can simplify. Now you'll see here that we now have a single term out front and a single term up top. Now they aren't exactly the same, so we can't just cross them off completely, but it does allow us to kind of inspect and look and see if there's something better that we can do. Okay, let's take a look. Now, they each have an x, they each have a 4. So if I were to break this down to 4x squared times x to the 3rd, you know that that is the same as what we have as x to the 5th. And if I were to break this down into 4x squared, okay, maybe I'll use parentheses instead of a times sign. That's kind of what I've been doing. Times 5, okay, that will give me that 20x squared out front, and then I'll include that x plus 1. And now we can see that what we have here is something that can be canceled. All right, we see this 4x squared and this 4x squared. And where did that come from again? That came from my factors of my original right here, right here, and right here. Anyways, so now we can cancel those out completely. What are we left with? We're left with an x to the 3rd on top and a 5 on the outside and an x plus 1 on the inside. The only other thing you could do, first of all, that's your answer. That's simplified. If you also had x to the 3rd over 5x plus 5, that is also correct. Tomato, tomato in that scenario. So look for your factors. Here's the big one. If you can take out a GCF, you can also factor with GCFs. Don't forget about that. This is a division sign. So how do I divide with fractions? Well, before I do anything, we got to use a little KCF, keep, change, flip. Remember, kids at home, never do keep, change, flip in reverse. That's a one-way ticket to the deans. Anyways, we're going to keep the first. We're going to change the second to multiplication and flip the last. Now, from here, we don't need common denominators. In fact, we could do one of two things. We could factor and cancel now, or we can multiply. If you wanted to multiply each of these two things by multiplying across, you can. It's just going to actually get more complicated. So what we want to actually do right now is we want to actually factor and cancel. How do I know that I'll be able to cancel? Because I've got a times sign in between. So right there, that's the Q. Time sign means factor, then try to cancel things out. And so let's actually go through that process. We've got a DPS right here, perfect squares. X squared is perfect square. 25 is a perfect square, and they're separated by a minus sign. So that's how we break those down. Keep the x to the third on bottom. Keep that time sign. Keep the 2x. We can't do anything with those. And now let's look for factors of 15. 1, 15, 3, 5. Anything else? Well, the 3 and the 5 will give us 8. So let's use them. X plus 3, x plus 5. Okay, now our whole kind of point here was to factor, then cancel. We have this factored completely. So before we put it together, let's see if anything will cancel. How do I know anything will cancel? When we have the same thing on the top and bottom. So let's highlight what we've got on the top and bottom. We've got an x minus 5. Oh, that's not right. Hold on. We've got an x plus 5 and an x plus 5. There we go. That will cancel. So let's just cancel those out and rewrite. So you might be able to see something else that cancels here. So I'm just running out of room. Otherwise, I would keep going down here. In fact, let's draw a little arrow. Let's make room. And so I've got an x minus 5 over x to the third power times 2x over x plus 3. And so you might be tempted to cancel out those x's, but now there's just a minus sign in between. So now what? Let's see. Are there any times signs in between things? Well, actually, this is all multiplication. And this is all multiplication. And so I got 2 times x and x times x times x. If I wanted to be very, very methodical here, here's how I can write this. X minus 5 over x times x times x. Yes, I'm being extremely extra, as the kids would say, over x plus 3. And now what we can see here is we've got times only separated by multiplication. A single x will cancel out from each the top and the bottom, right? That was that x right there, canceling with one of these down here. And so now there's nothing left that will cancel. This x minus 5 can't cancel out with anything entirely. That 2 can't cancel out with anything entirely. And I got 2 x's floating about. So we'll put this all together. It would be 2 times x minus 5 all over x squared times the quantity x plus 3. This is a simplified answer. You could, of course, distribute if you wanted to. I'm not making you. And in each scenario, this is what you'd get for your final answer. But I'm not having you do that. This was good. This is also good. Okay, so division, change to multiplication, keep, change, flip, factor, cancel. How did I know I could cancel? I had something on the top and the bottom. That's our rule with fractions, top and bottom. Then just see if there's anything else remaining that can be separated with multiplication, cancel that too, put it all together at the end. Number 10, a lot of us started to run out of space and time at this point. Number 10 is a subtraction problem. All right, so the first thing that I need to know when I have a subtraction problem is that I need common denominators. So we can obviously see that our denominators are not the same here. Okay, red flag. Is that what the kids still say? Anyways, how I'm going to get the best common denominator is actually to factor, to see what things have in common so that I don't have to just multiply these two things together. I don't want to have to multiply this whole thing by this whole thing. That would get really crazy. So let's see what we've got. All right, let's factor just the bottom here. Factors of 12 are 1 and 12, 2 and 6, 3 and 4. Will any of those give me a 1? Yes. If I make that 4 negative, all right, and so in that case, I've got x minus 4 x plus 3 on the bottom here. We'll keep that minus sign. And then over here, we've got a difference of perfect squares. 9 is a perfect square, and so is x squared, obviously. And so that's going to basically take the square root of each one of those with a plus and a minus. Now, these aren't still the same, but we can highlight something that is the same, which is really important. They each have an x plus 3. That doesn't mean we can cancel them out. That's not how this works. This is a minus problem, but it's going to help us see what we need to get together, what needs to be on the bottom of each one. So in this way, let me copy and paste this. Does that work? It doesn't work. Okay. In this way, I now see they have an x plus 3 in common, but this one has an x minus 3 and the first one has an x minus 4. So that's going to tell us what we need to add in. And so at this step, I'm going to take this and whatever it's missing that this one has over here, I'm going to put over here. This one has an x minus 4 that's missing. So I'm going to do that to the top and the bottom. This one over here, let's see, that it has an x plus 3. This one is missing an x minus 3. So now if I look, by adding what they were missing, now they each have an x minus 3, an x minus 4, and an x plus 3. The order doesn't matter because it's multiplication. So let's put this together now. I have 7x minus 3 all over that x minus 3, x minus 4, x plus 3. Yes, you do need to write this out. You'll see why in a second. Oh, yep. Sorry, I should have fast forwarded through this step. Okay. Now, what some people did, which is incorrect, is some people came through and they crossed off all of the bottom. What you were thinking of was equations. I'm going to put a little stamp here. Only cross off or cancel, whatever, denominators when solving equations. Just your classic half cursive, half not cursive, half cap, half not. So we can't cross this off because we're subtracting. We actually want to subtract the top and keep the bottom. That's what we do, right? If you were to think about a very simple example, 7/12 minus 1/12 is 6/12. Right? I'm not solving an equation. I was actually subtracting fractions. We subtract top, keep the bottom. So let's see what we get here. The next thing that you really got to be careful of is this negative here. Has to be distributed to everything. All right, so watch how I deal with this. The first thing I'm going to do is rewrite as 7x minus 3, sorry, 7 parentheses x minus 3 minus 3 parentheses x minus 4. So I put that whole top together and I'm going to keep the bottom. Bang. This is an answer. This is simplified. I've gone from 2 fractions down to 1, but we really want to simplify this a little bit more such that we can at least simplify the top. So if I look at the top, there's some distributive left over. And what you got to really see here is that minus sign on the 3, or it goes with the 3, right? That minus sign really goes with that 3, so that now I'm distributing a negative 3 to both of those things. So this is the real step. I'm going to star this in a second, that most of us really have to be careful with. This is where a lot of us miss points. We have 7x minus 21 on top. What's negative 3 times x? Negative 3x, but now I've got a plus 12 all over that denominator. X minus 3, x minus 4, x plus 3. And of course, this is better. Now let's just combine a few more things. Let's see, the 7x and the 3x can combine, and the negative 21 and the plus 12 can combine. And we end up getting, let's see, 4x on top. That 4 looks weird. 4x on top minus, oh, doctor, 21 minus 12. Yep, that's going to be negative 9. And now we've got all of this left over on the bottom. So one stamp that I really want you to have as a takeaway is we can only cross off that denominator. Yes, that's the shortcut of the word denominator when solving an equation. So notice how I left it the whole time there. And the other thing that I want you to take away is that this minus sign right here goes into both of those. So it turned this into a negative, and then it turned that -4 back into a positive. So this is my simplified version of my final answer. This is fully simplified. This is the only way you can get full credit. Go ahead and try your own. Number 11, this was the longest problem on the test. This one is solving. So if you don't get x equals as your answer, did you solve? No, you need to factor and then solve. So we're going to do some things, put some things together first. Remember, we could cross multiply if there were just one fraction on each side, but this -1 is kind of sticking in the way. So we can't use cross multiplication to solve this one. And in fact, what we're going to do is we're going to try to get all of these denominators the same and then cancel them out in this scenario. All right, so let's first make sure this is really, really silly before I go back there. Let's make this, oh jeepers. Let's make this -1/1. Okay, convert all to fractions when solving, or even when adding or subtracting fractions. Okay, so in that scenario, now I can actually look for a common denominator. So I'll put CD over here and I'll actually look for a common denominator. Let's factor this first. That's going to help us. Nothing factors over here. And in fact, the only thing that factors is this x squared plus 2x. And a lot of people said that was like x plus 1, x minus 1, x plus 2, x minus 2. But you can't do that. There's really just a GCF problem. They each have an x, so just take out an x. All right, if you ever have a GCF, just take it out. Because what you have remaining, there might not be anything else to factor, and x plus 2 can't be factored. So this is the most factored form. So let's look at what we want to add in here to get common denominators. Well, this middle fraction has nothing. So that middle fraction is going to get this whole thing. It's going to get times x plus 2, and it's going to get times x plus 2 on top as well. Well, I'm just multiplying it by 1, so you can imagine it's just going to be x plus 2 on the top and bottom. For this left one, let's look at what this one is missing. It's missing an x, so let's multiply the top and bottom by an x. Now let's rewrite and see what we got. We've got x times the quantity, 3x plus 3. I'm showing all my steps. I'm being very deliberate here. And then I've got x times the quantity, x plus 2, minus, well, let's see, I'm multiplying by 1, so that's just going to keep it the same. X times the quantity, x plus 2, and x times the quantity, x plus 2, equals, I didn't have to do anything to this one. I had to just keep it because it was already set with the right denominator. It had everything. There's nothing that needed to be added. And so since I'm solving an equation, and this is much different than the previous problem, but since I'm solving an equation, now we can go through and we can cancel all of those out because each fraction has the same denominator. And so now we'll take a moment and rewrite this. The one thing that we got to be careful of is this minus. So watch how I rewrite this. We're going to rewrite this as x. Yes, I'm being extremely methodical here, because some people are losing their negatives, and I don't want that to happen to you. Because what you're going to see here is in this scenario, we've got to make sure that we multiply both of these by a negative. And so although we've gotten rid of the bottom, let's distribute here and be careful to distribute that negative that came from where? That came from the minus sign in this problem. So we get 3x squared plus 3x minus x squared minus 2x equals 3. This is a quadratic. We can actually put some things together now. We have some like terms there. 3x squared minus x squared turns into 2x squared. We've also got some like terms here with the 3x and the negative 2x. That gives us a plus 1x. And now remember that we want to get this equal to 0. So I'm going to bring that -3 over. And now we've got a quadratic that we can solve. Well, how do I solve this quadratic? Remember, that's the whole point of this. We've got to factor with grouping. A times C is -6. Why? Because the A term's not 1. 1 and 6, 2 and 3. Which of those will give me a positive 1? 3 and 2, as long as the 3 is positive and the 2 is negative. So we're going to make this 2x squared minus 2x plus 3x. Sorry, I just ate some popcorn and I've got a kernel that's tickling me. If anybody cared, you probably don't. And so now factoring by grouping means we're going to take out whatever we can in each one, which is going to be a 2x and a 3. We're going to get an x minus 1 and an x minus 1, which means we've got 2x plus 3 and x minus 1, which when we solve would give us a negative 3 over 2 and a positive 1. Whoa, okay, we finally got x values. So what? We got to remember to check. So let's go back up and check, and let's look at our denominators. The best way to check is to look at your denominators whenever you cross those out. The only things that would not be good, x cannot equal 0 and x cannot equal negative 2. Because if I got either one of those, I'd get 0 in the denominator. That'd be undefined. That's not a real solution. And so in that scenario, let's look. Do I have 0 or negative 2? No. So both of these are good. I'm going to tell you that on your exam question, you have to check because one of them might not be allowed as an answer. Take a minute, rewind this, see what I did. Understand that with solving, we want common denominators to cancel. With a quadratic, with an a term, not 1, we need grouping. And once we get those factors, we need to solve, and then please I dare somebody to just yell out at the top of their lungs, check. Anybody got it? Anyways, thanks.